Welcome back, algebra students, to section 4.1. We are doing negative exponents today, so get ready. This is kind of the tricky part for exponents for a lot of people. They kind of lose it a little bit when they talk about negative exponents, but I'm here to tell you it's not as bad as you might think. Now, why even have a negative exponent? Well, first off, it's not the same as negative numbers, okay? It's not going to be, for example, if we have 3 to the negative 2 power, it's just not negative 9. That's not how it works. Negative exponents are an easier way for computers and programming to use fractions within their coding, okay? So when we're talking about negative exponents, it's an easier way to write the following. A to the negative n is going to be equal to 1 over a to the n power. Okay? So what happens is anytime you have a negative exponent, it gets turned into a fraction. So this becomes that as you have a negative exponent. A way I like to think of it is, let's say you have x to the negative n. This just becomes, anytime you have a negative, you know you have to put like this. I go like this, and then I extend that negative sign. So there was a negative n here, right, like that. Okay, I'm going to extend that, and I'm going to move this down, and then I put it in the denominator. Okay, so that's a way to think of it. It's like the start of a fraction. You know you have to put it in the denominator of a fraction. Okay, so these are actually pretty easy. They're going to be recognition most of the time. So for example, 2 to the negative third power is going to be equal to, okay, 1 over 2 to the third power. 1 over 2 to the third power, and that becomes 1 over 8. All right, but the main thing is, can you recognize this? 1 over 2 to the third power. 6 to the negative 1 is going to become 1 over 6 to the first power, and that's going to be 1 over 6. Okay, it's not bad. Don't think negative, like negative numbers. Think about, okay, it's a negative exponent, so we're just changing how it looks first. So if we have something like this, now we have outside the parentheses, and we have to apply it to both inside. Or we can just keep together using the parentheses. Okay, don't think that this only applies to the z. So we're going to say, okay, 1 over 5z cubed. So now this cubed, now that we changed it from a negative exponent to a positive exponent, we can distribute both of these, and we can say that's the same thing as 1 over 5 cubed z cubed, okay? Because we have to cube both things inside the parentheses if there's an exponent waiting outside, okay? Now we can evaluate each one of those individually if we wanted to, so that'd be 125 z cubed. Now, the first thing you should always do with negative exponents, and I should have kind of led with this, is you first want to rewrite, that's not how you write, rewrite into a fraction. You always want to do that first. So let me capitalize that, first. You always want to rewrite it into a fraction first. Okay, so now this is very similar but different than letter C. So we have 5z to the negative third. Notice how there's no parentheses here? So what do? Well, the only one that has a negative exponent is this guy. This guy, the 5, he doesn't have a negative exponent, so why should he have to move? This is a little confusing for people, so I'm trying to break this down as simple as possible. Because z has a negative exponent, we first need to rewrite him with a positive exponent. Did I write that? Rewrite into a fraction first. Rewrite into a fraction first, and then I guess I'll put this with positive exponent. There. That's kind of implied, but I should have written that more explicitly. So you have z to the negative third, so this turns into 1 over z to the third. This 5 does not have a negative exponent, so he just waits out front patiently. Now what happens is this. The 5 is just going to remain in the numerator. Okay, so 5 times 1 over z cubed is just going to be 5 over z cubed. And that's become our final answer there. Okay, you'll notice that there's these little disclaimers that it can't be equal to 0. because if we had, for example here, if we had 5 times 0, that would be 0. And so it would change the value of the whole thing. Okay, so it can't be equal to 0. All right, here we go. Now, same thing here, but now we have a negative sign out in front plus a negative exponent. You're thinking, oh my gosh, too many negatives. It's not that bad. So look, we have negative 1, and if we want, oh, sorry, it looks like just negative m. If we want, we could change this to negative 1 times. Anytime you have negatives out in front with an exponent, sorry, I messed this up. With an exponent, we're always going to do the exponents first and then apply the negative at the end. I think we had a problem like that earlier in the previous section, so just keep that in mind. So what we're going to do first is we're going to rewrite the negative exponent first. We don't like that. So we're going to change this to a positive exponent. What does that become? It becomes 1 over m squared. Now, there's still that negative out in front. If you want, you can say, okay, that's negative 1. I'm sure that confuses people, so I'm just going to leave the negative. Now we can say negative 1, I always like applying the negatives to the top, over m squared. There's your answer. Here's another case. Look at, now we have it in parentheses. What happens here? Because the negative's inside the parentheses, now we're applying that whole thing to this negative exponent. Okay, so see the difference. Parentheses, exponents, multiplication. The first time we didn't have parentheses, so we just did exponents, multiplication. So it changes the order a little bit with parentheses. So now we're going to rewrite this into positive exponent into a fraction. So we're going to have 1 over negative m parentheses squared. So see, the first thing I did is I rewrote it into a fraction with the positive exponent first. Okay. Now I have 1 over negative m squared. Well, negative m squared is just going to be positive m squared, because a negative times a negative is a positive, so we get 1 over m squared. So a little bit tricky there, a little bit of nuance, but I hope you can recognize that if it comes your way in the future. All right, here we go. Now we have a little bit addition going on in addition to what we're doing with the exponent. So we're going to rewrite these first. 1 over 3, I changed colors. 1 over 4, to the first, plus. So that's 1 over 3 to the first power, 1 over 4 to the first power. So it's 1/3 plus 1/4. Hopefully you're good at fractions. I have fraction videos, I think, on the subject, so if you need some help, I got you covered. We need to find a common denominator. It's going to be 12. 3 times 4 equals 12, so we need to change that to 4. 4 times 3 equals 12. We change that to 3, so we get 7 over 12 as our answer. The main part, though, is changing these negative exponents to positive exponents written as a fraction. We have, for this guy, 1 over 5 to the first power minus 1 over 2 to the first power. Okay, so then what we're going to do is we say that's equal to 1 over 5 minus 1 over 2. Common denominator is going to be 10. So this is going to be 10. This is going to be 10 with the minus sign, multiplied by 5, multiplied by 2. And that's going to give us negative 3 over 10. There's our answer there. So I went quickly, but that's like kind of review. And the main thing is rewriting those fractions. Okay, this is the tricky one. So this is a good one to end on. Oh, well, we have one more thing. But for the examples, this is a good one to end on. Now we have 1 over 2 to the negative third power. Okay, now you're thinking, oh my gosh, too many fractions, negatives, this is like too much. Take us step by step, okay? Calm down, deep breath. Leave the 1 there, okay? Stick to our fundamentals. Our fundamentals is this, that we rewrite this as a positive exponent in a fraction. So what does that become? This becomes 1 over 2 to the third power. Okay, now the problem is we have a complex fraction here. What we need to do is we need to rewrite this. So first we can say this is the same thing as 1 over 8. I think that makes it a little bit easier so we don't have to worry about so many numbers. Now, anytime we divide, it's the same thing as multiplying by the reciprocal. So this technically could be rewritten as 1 divided by 1 over 8. Okay? Those are the same thing. These are the exact same thing. 1 divided by 1 over 8. So we can change this to 1 times the reciprocal, 8 over 1. So this becomes actually 8. 1 times 8 over 1 is just 8. So that's going to be our final answer here. And I'm going to talk about some shortcuts in some future videos of how to quickly do problems with negative exponents in the bottom and in future videos, so stay tuned for that. So now we're going to talk about last thing before I let you guys go, special rules for exponents. If a is not equal to b, or a is not equal to 0 and b is not equal to 0, then we have these three conditions. 1 over a to the negative n is going to be a to the n. Okay? Now, this is like one of the keys, one of the tricks I was talking about. Anytime you have a negative exponent in the bottom, it essentially moves to the numerator. So if you want, think of this as a to the n over 1, or just a to the n. Okay? But it moves to the numerator. If it's in the bottom and it's negative exponent, it goes to the top. If it's in the top and it's negative exponent, it goes to the bottom. Let me demonstrate it with the next one. A to the negative n over b to the negative m. What happens is, just as I said, if it's negative exponent in the bottom, it's going to move to the top. If it's a negative exponent in the top, I'm going to change the color, it's going to move to the bottom. So this is going to be a to the n in the bottom. In the top, we have b to the positive n power. So see how they just flip like that? That's the kind of the trick of negative exponents. Okay, and then if we have this whole thing raised to the negative n, then what we're going to do is we could write it as 1 over a over b to the n like this. But what's going to end up happening is it's just going to switch. Okay, it's just going to end up switching. So it's going to be b to the n over a to the n. I could break that down if you really want to. Leave a comment if you want me to do that. I guarantee, almost guarantee you don't. But this is how it ends up, is you just flip these because of the negative exponent. Okay, so these are our three properties of special rules for negative exponents. Stay tuned for next time. Next video, we're talking about the quotient rule for exponents, and then we're going to talk about the power rule because the quotient rule doesn't take that much time. Hope to see you then. Hope you enjoyed this video. Thank you for watching.